Alright, so what do we do if we have a quadratic factor that leads to a partial fraction of this form? And we know we can't factorize it like this, where we had real roots, so that we can write it like this. It doesn't have real roots, it will have complex roots. And I'll show you an example of that as well, if you really must. But now we'll take an example. For example, 1 over s squared plus 2s plus 2. And this will have complex roots, and you can check it. The discriminant here will end up being equal to -4. So we get complex roots. Now, where I want to go with this is to write this as something of the form that we can find in a Laplace transform, and in this case I will write it as 1 over s plus 1 squared plus 1. And now if we get the book and we have a look at the Laplace table, we have a couple of options. We know there is no s in the numerator, so we can write a constant there. And let's see. Yes, if we look at different Laplace transforms, but in particularly those for e to the powers minus at times sine of bt, we will see that this ends up being b over s plus a squared plus b squared. And just note that these a's and b's have nothing to do with a's and b's. This is just letters. And if we look at e to the power of minus at cosine of bt, we get s plus a over s plus a squared plus b squared. Alright. Now that will, I'll just erase this, and this should give me a clue as to where I want to go. So I'm looking for the form s plus a squared plus b squared, and if I were to work that out, s plus a squared is s, well, I'll just add the b squared here, is equal to s squared plus 2as plus a squared plus b squared. And it's this 2as I would like to focus on. Here we have 2as and here we have 2s. So this is going to be something of the form s plus 1 squared plus, yeah, something. And I'm not entirely sure what that something is. But I know that if I work this out, s plus 1 squared is s plus 2s plus 1. And the difference here is, well, there's 2 there, so the difference here is 1. And I can write it like this. Now, of course, this is a very simple example, but this apparently, if I want to take the inverse Laplace transform of this, I can look up at the table and say, well, hang on, it is in this form. So this will become e to the power of minus 1t, because we have a 1 here, times the sine of, well, t, because we have a 1 here. Well, what would happen if I had and I'm just going to change some things, and I'll do that with red. If I had not 1 here, but I had 4 here, this would be 4, and because of the linearity properties of the Laplace transform, I would still have 4 here. So we don't factorize the, so we don't take the complex roots of a partial fraction in this form where we have this condition. We leave it like that and then use the information we have from the Laplace transform to solve immediately for this, or a combination thereof. And later, when we go into Laplace form a bit deeper, I'll show you a couple of more things of